This is problem 5.45, and we're talking about word typo errors. So it tells us essentially that humans typically catch about 70% of word errors in a document. We have a document that we know has 10 word errors. And we want to know what would be the distribution of errors that a random person would catch. So if this person can catch 70% of word errors, generally, what's the distribution for the errors that they would catch? So looking at this would be a binomial distribution, because each error should be independent of the next one. Like if you miss one, that shouldn't affect whether or not you miss the next one. So we could say they're independent. We know that there are 10 possible errors to choose from. We know the probability of catching each error is 0.7. And you either catch it or you don't. So either catch or miss. So those are our qualifications to be a binomial. So this would be a binomial. With n equals 10, because there were 10 possible errors, and the probability of catching each one is 0.7. Now it asks, what's the distribution of the errors missed? Well, this is the exact same thing, because you're either catching it or missing it, so we can just change it around. There are still 10 errors, and if you have a probability of 0.7 to catch it, then your probability would be 0.3, or 1 minus 0.7 equals 0.3, 0.3 of missing it. So this is to miss. So we know it's a binomial distribution. Now they ask, what's the probability that you miss more than 4 out of the 10 errors? So we're looking for the probability that x is greater than or equal to 4. To find this probability, you'll have to do each one. So the probability that x equals 4, plus the probability that x equals 5, plus the probability that x equals 6, plus all the way up to the probability that x equals 10. There's two ways you can do this. We do have a table. You can just look at the table, or you can try and do it by hand. So I'll show you how to do one by hand, then I'll show you how to do it by the table. So in general, the probability that x equals some specific number is going to be equal to n choose k, where k is the specific number you're looking for, times the probability raised to the k power times 1 minus p to the n minus k. So in our case, the probability that x equals 4, well, n is 10, so we're going to do 10 choose 4. Our probability of missing is 0.3, so we want to miss 3 errors, or 4 errors, so 0.3 raised to the power of 4. The probability of not missing or catching it would be 1 minus 0.3 raised to the 10 minus 4. So that means we need to actually catch it with a probability of 0.7. We need to catch it 10 times if we're going to miss it 4 times. Put this into your calculator. If you don't know how to do this 10 choose 4, then go check out my videos on combinations, because there are a couple on the lesson page. There are also a couple sites you can read, but you should just be able to put it in your calculator, which gives me 0.2001. Again, this is 10 choose 4. If you don't know how to do it, go look for the things on the lesson page. Now I'm going to show you how to use the table. So you go to your table. We're looking for something that has an n of 10 and a probability of 0.3. Notice this page has probability of 0.3 and goes up to n equals 8, so let's keep looking. This has an n of 10, but my probabilities are too small, so keep looking. Okay, so this page has an n of 10. Here's my probability of 0.3. Okay, come down to the table. The probability that x equals 4 is 0.2001. The probability that x equals 5 is 0.1029, 0.0368, 0.0090, 0.0014 is the probability that x equals 9, and the probability that x equals 10 is 0.0001. So if you add up all of these probabilities, that's the probability that x is greater than or equal to 4.